What's up, y'all? How y'all doing? Today I'll be introducing you, my dear viewers, to my girlfriend. You see, Transformers is, well, the most frequently used device in my videos. Well, you guys can all see it, and, well, I really love the device. So much so, I tried to kiss its spark.
Oh my god, bro. Oh, hell.
What is a transformer? A transformer, you see, is a device that consists of two coils mounted on it, the primary and secondary. And this device helps us convert voltage and current interchangeably on two different coils. Let me explain. Well, I think my amateur drawing makes it better, so here. Now, there is a wire mounted on something called an iron core, a ferrite core. That mounted wire is called the primary coil, and the other side is called a secondary coil. And I think this is pretty much easy. When the primary coil's turn, which we call NP, number of primary, is less than the secondary coil's number, or the number of coils, NS, then this transformer acts as a step-up transformer. The thing that steps up is the voltage. Here, when we apply electricity to the primary coil, we apply two things, the voltage and the current. Now here, the voltage Vp in a step-up transformer, Vp is always less than Vs. Vice versa to it, the current Ip is much more greater than when compared to the Is form. Right here, as I said earlier, Np is much more less than Ns, Np is much greater than Ns. Anyways, it's just as you see it. See, when the voltage rises, the currents drop, but it does not change the value of something called power or electric power. And if you multiply the voltage and the current in the primary and the voltage in the secondary, if we measure them, it becomes almost exactly equal, which shows us transformers don't create energy out of thin air. All they do is transform, but they inevitably don't create or destroy any kind of energy or power itself. So yeah, you see, if we brought two cores, iron preferably, and mounted the two of them at two different wire setting, just like this, apply electricity in one coil, and this magnetic field is just built, and the moment we connect the voltage to this primary coil, let's just say it's primary coil, the secondary coil picks up those magnetic fields, and something that we call mutual inductance happens. When this coil picks up magnetic field, they use a Henry's law or Faraday's law. To be honest, it depends. This is what we call magnetic flux. Magnetic field is just the amount of magnetic field through an area. And over, just here, divided by change in time. Here, what it tries to imply is there must be change of magnetic field in certain amount of time. Which means, in general, magnetic field must change for this voltage to be produced. And I forgot, there's minus sign. My video, I try to make a high voltage out of contact breaker, because we need to literally break the contact of the electricity to create a changing magnetic field, so we can create a high voltage in the video that you've seen before. We always should use a AC current or an alternating current for this particular reason.